All right, guys, welcome back. This is, what's today? Wednesday's lesson for applied math. We're still going to be working on 2.3, so empirical probability versus theoretical probability, or experimental versus theoretical. Again, remote learners, let me know if there's an issue with this video. Hopefully it works. So, did you guys find the page in your notebook? Awesome. Cool. I'll pass out calculators. Here we go. Alright. So, we got a deck of cards. It says, Amanda used a standard deck of 52 cards and selected a card at random. She recorded the suit of the card she picked and then replaced the card. And the results are in the table. Okay, so it looks like...
There are 30 cards altogether.
So you're saying 30 altogether. Hold on. Jared, how many diamonds were there?
Yep, there were about 7.
7. Very good. Hearts?
9.
9.
11 spades.
Yep.
3 clubs.
All right. And so then you said there were 30 altogether?
Yeah.
There were. Very good. Because 9 and 11 is 20, 7 and 3 is 10, 20 and 10 is 30. Okay, so based on the results, what is the experimental probability of selecting a heart? So based on this chart, what's the chances of getting a heart, you guys? Any takers?
Let's see, there's 9 cards out of 30.
Yeah, 9 hearts out of 30. What'd you say, Dan? I just couldn't hear you.
3 times.
All right, and Dan says 3 tenths. So let's put this in the calculator. 9 divided by 3. Math enter. Oh, hey, Miss Deck, the calculator's not on. Still not on. Hey, great job, Dan. Your brain is working much better than mine. All right, so 3 out of 10. Perfect. All right, number 2. What is the theoretical probability of selecting a heart? So not using the chart. How many hearts are there in a deck of cards? 13. 13 out of 52, which reduces to
1/4.
very good. That we definitely have down pat. We know that a fourth of the deck is a certain suit. All right, number 3. Based on the results, so back to the chart. What is the experimental probability of selecting a diamond or a spade? Alright.
3, 7, 30. 7 out of 30.
Okay, well, let's see here. So there are how many diamonds? 7. How many spades? 11. 7 plus 11 is 18. 18 out of how many cards did we pick?
It's 6 counts, which reduces to 3 votes.
Alright, let's see if Dan is correct. Bravo, bravo. 3/5. Love it. Alright, number 4. What is the theoretical probability of selecting a diamond or a spade? Okay, so not using the chart. How many diamonds are there?
13, add the 2 up there, you get 30. 26.
Yeah.
Divide that by 52.
Would you guys say odds are in your favor?
Yep, you get 1/2.
Very good, 1/2. Alright, so compare these results and describe your findings. Well, you guys, when, how would you do, let's see here, 3 out of 10, let's compare 1 and 2 first. We'll compare them using decimals. So 3 divided by 10 is 0.3. 1 divided by 4 is 0.25. So which one's greater, 3 tenths or 1/4?
3 tenths.
3 tenths. So odds are in your favor for selecting a heart based off the experimental probability, right? Like this one had a better, whoop. I'll put a star there to show it had a better chance of occurring. Alright, now let's see the spade one and the heart one. We'll compare those two. So 3/5 is 0.6 versus 1/2, which is 0.5. So which one is greater, 3/5 or 1/2? 3/5. Oh, again, the experimental probability won. So which had a better opportunity of happening? The experimental situations or the theoretical situations? Experimental, yeah, okay, so that's how we can describe our findings. There are other ways too. You could say that you're less likely using theoretical. Let's try to be more positive though. So experimental probability was greater. You could also say a bunch of other things. Anyone else have an idea of what they'd want to say? Or you're
There's a
okay?
greater chance.
Greater chance. Yeah, I like that. Awesome. So it kind of makes you want to like take the chance versus actually doing theoretical situations. Okay, so now we're gonna talk about students in a class. So we're gonna step away from a deck of cards. Alright. So Dale conducted a survey with the students in his class to observe the distribution of eye color. The table shows the results of the survey. So his students had blue eyes, brown eyes, green eyes, and hazel eyes. 12 of them had blue eyes. 58, wow, had brown eyes. 2 had green eyes. 8 had hazel eyes. Can I see your eye colors? John, you got blue, looks like? Green?
I got
Hazel?
brown. I got brown.
You got brown. Yeah, that's an easy one to tell. I think yours are blue, right?
I'm gonna change between.
This is done as are blue. Mine are brown. Alright, so we got a majority of, actually we have 2 blues, 2 browns, 1 hazel. That's pretty interesting. Cool. Alright. So let's look at this data and we're going to answer the questions. Find the experimental probability distribution for each eye color. Alright, so blue. How many were blue?
12.
12. 12 out of how many?
80.
Alright, let's see here. Jared says 80. I'm just going to double check because these numbers are getting large. 12 plus 58 plus 2 plus 8. Very good, Jared. So we have a total of 80 students. What does that reduce to be? I'm also wondering if those are 80 students or 40 students. Like he did a pair of eyes, but I'm not going to overthink this. Very good. So 3/20. All right, brown. How many were brown?
58 out of
58 out of 80. That also reduces for sure. What it reduces to, I have no
49
idea.
out of 40.
29 out of 40. Alright, green.
1 out of 40.
Good. 2 out of 80, which reduces to 1 out of 40. And hazel.
110. Yep, I
Very
got that as
good.
well.
110. Okay, you guys. Based on the survey, what is the experimental probability that a student in Dale's class will have blue or green? Alright, so John, you said 14 out of 80, very good. And then let's see what that reduces to.
740s.
7/40ths? No, enter. Whoa, math, enter. Very good. Alright, Based on this survey, what's the experimental probability that a student in Dale's class does not have green or hazel? Alright, so if they don't have green or hazel, what color eyes do they have? Brown and blue. So,
Looking at 70.
let's see here, brown is 58, blue is 12, 58 and 12 is, I heard you.
7/8.
Yeah, 70 over 80, which is 7/8. Pretty high probability. Alright, if the distribution of eye color in Dale's grade is similar to the distribution in his class, about how many of 360 students in his grade would be expected to have brown eyes? Oh, this is like the problem we did yesterday.
Yes.
Do you remember? And I think Dan helped us. What did we do first? We divided first.
The number of students without it.
Well, okay, how many students were in the survey at first, or were in the study at first? 80. And we want to know how many times 80 goes into 360. So let's see here.
Is it 4.5 or?
4.5, and I think actually yesterday we got 3.5.
Yeah, and I got, which would be 9. Should be 9.
Alright, then we have to multiply that by how many students have brown eyes. How many students have brown eyes in his class?
58.
58.
Which equals 261.
Yeah, so there could be a lot of them. 261 students could have brown eyes. It might actually happen.
That it?
Alright, do you guys have the one about the sock drawer being a mess? Oh yeah,
Yes.
just on the back. Alright, last situation. Whose sock drawer at home is a mess?
Not mine.
Do you guys always have all your socks paired up?
Usually.
Yes, no? Dan? No, you don't, you just throw your socks in a drawer? You're like
No,
Mr.
no,
Duck.
they're paired, but like.
Mr. Duck just throws all of his socks in a drawer, he does not pair them up, I don't know how he does it. What about you, John?
Most of my socks are